Questions on the homework? 64 on 5.2. Okay, this is questions on the homework 5.1. Oops. I love when it does that. 5.1 and 5.2. 64 on 5.2.
Yeah.
Okay, let's look at that one. 5.2, number 64. Okay, have a squared plus 2ab minus 3b squared. Okay, when you factor it, they don't have anything in common with all three terms, so you can't factor like just an a or a b out. So we know we're going to just be doing a factor like this. Okay, a squared, we know we'll have a and a. The end here, b squared is part of it. We know we're going to need a b. Okay, the 3, the ways to get 3 is only 1 times 3. So you know you're going to have a 1b and a 3b there. Okay, they're going to need to subtract to give you 2, a positive 2. Okay, when they subtract, that means they're different signs. Okay, so which one is going to be positive and negative here? Positive 2, so which one's positive? The 3 is positive. And the answer probably did not have the 1 here. You won't see 1s usually as a coefficient in your answer. So your answer probably shows like this or the other way around, which either way is fine. Either one of those. Okay, and there was a question on 5.2, I believe, 16 and 17. Yeah. Okay, if you look at 17 and 18, sorry. On 5.2, if you look at number 17, which is in the back of the book, if you try to factor that, you have x here, and 1 has to be 1 times 1. But when you add it, you can't get the coefficient of 1. You have 1 and 1, so it could have been a 2. But it can't be this. So since that doesn't work, the answer is prime. And number 18 is the same way. X squared plus 5x plus 3. Okay, when you try to factor it, you would put x and x. 3 has to be 1 and 3. To add them to get 5, there's no way you can add 3 and 1 to get 5. The middle could have been 3 plus 1, 4, or that could have been subtracted. You could have had a 2, positive or negative 2. Yes, ma'am?
Where do they come up with the word prime?
Because they don't have factors. Remember, the prime numbers are like 2, 3, 5, 7, 11, 13, like that. Okay, think of a number that's not prime, like 6. It has the factors of 2 times 3. See, it has factors. This is a composite number, and these are prime numbers. It's only 2 times 1. It's only itself times 1, or it's only factors. This has no factors, so it's prime.
I get it.
Kind of like a prime minerals. One mineral is just it's very good to have one mineral. Like if you have solid gold, that's prime. That's a prime mineral. A lot of money for that. You end up with a rock that has a whole bunch of copper and a little bit of turquoise. It's a composite mineral of copper and turquoise. Composite is like mixed up. It's got more than one thing in there. Okay, so prime, it just has itself. Any other problems on the homework that you want to do? You want to do some of the grouping very end of 5.2, or which, is there any ones that you missed that you'd like to do before we go on to the next section?
So the answer for this is
No? How about the fraction one? Did anybody miss the fraction one on 5.1? Was it 5.1?
Calculator.
Yeah.
43.
Okay, instead of doing the one from the homework, let me do the one that was right next to it. And make sure, while we do this as a daily quiz, everybody try to do this real quick. Off to the side, everybody's this will be a one problem daily quiz. Okay, girls? Somebody wake them up. One problem daily quiz.
Because there were negatives.
Okay, there's your one problem daily quiz.
That's a positive figures. Yeah, they're positives here. So they can be either way. You can either say negative.
Girls, are y'all doing the daily quiz?
No.
It's a quick problem.
Oh, sorry. Those are not nice.
If I could pause the video, I would, but it turned off, so I'm not going to pause it for this. Still see a few people writing. Okay, the coefficient part, the number in front of the x, what do they have in common here?
9.
The bottom.
9.
9. So it's 1/9, right? And what's the smallest x?
The single X.
Just 1, right? Okay. Now to do the rest of this, what do we do for this?
5X to the 6th power.
5, and then 6 more x's, right? Put your plus. How about for this one?
2X, 4.
2, and then 4 more x's. Now there's a minus.
4X cubed, or squared.
4x squared minus 1. It's got the 1/9 and it says the x. Okay, how many people got that? Not too many. Let's do another one. We have 2 daily quizzes today. I don't have another fraction one on here. I guess I'll have to make one up. Okay. 3/8 x to the 6th plus 2/8 x to the 5th minus 5/8 x to the 4th plus 7/8 x squared plus 1/8 x. Ah, sorry. Don't have it where you can see the whole thing. This one should go faster. Okay, what's the greatest common factor? What's the number part in the front?
8.
They all have 8s in common, right? What's the smallest x?
1.
Just 1x. Okay, to get this term, 3. 5 more. 5 and 1 give you 6, okay? And then plus 2 x to the what? 4 minus what? Plus just x, okay? Plus. Now, how many people got it right? A few more. Okay. Should we do one more? Most of you got it right. The rest of you can watch these two and do it at home. Any other questions on the homework? Want to do some grouping? Nobody had trouble with grouping? The grouping ones were, is that on 5-1? Yeah. Let's do one grouping one just to make sure you can do grouping. 2x to the third power plus 12x to the second power minus 5x minus 30. This is grouping, so group the first two and second two. Okay, so what does the first two have in common? 2 x squared. And then this, you need x plus, you need a 6, right? Does everybody see that? They had 2x squared in common. To get the first term, we did x. To get the second term, we did plus 6. Now we need an x plus 6 over here. How are we going to get negative 5x? Multiply it by negative 5, right? Negative 5x, negative 5 times 6 is negative 30. Okay, so they have this in common. X plus 6, 2x squared minus 5 is your other one. How many people got that before we did it? We do need to do another one. One more grouping one. Okay, 18 x cubed minus 21 x squared plus 30x minus 35. Grouping. Okay, the first two have a 3x squared in common, right? These both divide by 3, x squared is the smallest. How are you going to get the first term? 6 and an x. This gives you 18x cubed. Okay, to get the second term, minus 7, right? Write this over here, 6x minus 7. Okay, what are we going to multiply to get the first term here? Positive 5, right? This gives you 30x. This gives you negative 35. So that's right. They have in common 6x minus 7 and 3x squared plus 5 is your other term. How many people got that one? More? A few more? Should we do one more? Just one more. Sorry, that was going to be the last one. We keep doing one more, one more. X squared plus 2x plus 3x plus 2. People at home can just zoom through this. Sorry about all the delays here, but I'll give them extra practice too. Okay, what do these first two have in common? No number, just the x squared, right? Okay, factoring that out, how do we get the first term? 3x, just 1, right? 2 and 1 gives you 3. Plus, and you don't need any x's. Okay, write this over here, 3x plus 2. How are we going to get this first term? Just 1. Plus or minus? Positive 1, right? So they have in common 3x plus 2. And what's your other term?
X squared plus 1.
How many people got that? More people? Good. Okay, now we're going to go ahead and go to the lecture. And your homework, you can go ahead and pass them up, and I'll gather them up later and get them back to you. Okay, the syllabus says we skip 5.3 and 5.4, right? It says to omit. We're skipping 5.3 and 5.4. So now we're going to do 5.5. 5.5, you're still factoring. These are special things that we're factoring. We're factoring trinomial squares, and we'll be factoring difference of squares. But first we're going to do this. What's a trinomial? 3. Has 3 terms, right? Okay. For it to be a perfect square, what it means is, let me show you one that we're going to factor first. And I'll show you why it's called a square. I keep breaking. X squared plus 6x plus 9. When you factor that, you would put 1 times 9 or 3 times 3, right? Okay. The ones that add to give you 6 are the 3 and 3, right? So x squared is x times x. 9 is 3 times 3. And they're going to be positives. Okay, see how it's the same thing twice? That's x plus 3 squared. That's the type of things you're going to be factoring now. Okay? They won't be two terms. It'll be the same term done twice. Okay, it may have a minus right here also. It could be x squared minus 6x plus 9. You're still going to use the x's and the 3's, but since this is a negative 6x in the middle, they're both going to be negatives. So this one is x minus 3 squared. Okay? So that's the type you're going to be doing. So you know that you're not going to use the 1 times something. You're going to be using the one that's times itself on all of these. Okay, let's do one like, let me get one of the first ones here. 49 plus 56y plus 16y squared. How are you going to get 49? 7 times 7. We don't go into the 1 times anything here. How about this? We know we need a y on both of them. And what is times itself for 16?
4 times 4.
4. What is it called when we're trying to figure out what times itself is that? It's called a square root. It says what squared or times itself is that? Square root of 49 is 7, square root of 16 is 4. Okay, let's see if this is going to work out. We need a positive because they're both positive. The middle term has to be positive, so we're both positive. Okay, middle term, 28y. The outside term, 28y. What do they add up to? 56. Okay? So when you're looking at a problem like this, let me show you what the definition for a trinomial square is. If you have a squared plus 2ab plus b squared, okay? This will factor out to a plus b squared. In this term, what was a? What squared is 49? 7, right? So a was 7. And what is b? 4y. The square root of this whole thing. b is 4y. Okay? So a squared is 49. 2 times a times b. A times b, ab is 4 times 7, 28y. If you double 28y, there it is. And then plus b squared, 4y squared is that. Okay? Because you're gonna have some problems that ask you, is this a trinomial squared? You're either gonna have to factor it or be able to recognize if it's 2 times the square root of that times the square root of that. 2 times a times a and b. Okay? It may be easier just to factor it and see if it came out to something times itself. Okay, there's another squared, the one with the minus here, the exact same thing, minus 2ab plus b squared. This will factor into a minus b squared, which is what we saw right here. here, A is x. A was x. B is the square root of that. B is 3. See? A squared. And then minus 2 times that. Minus 2 times 3x is minus 6x. And then you have plus b squared. Plus 3 squared is 9. Okay? So it may not be as easy to recognize, but if you get to where you can recognize it, you can just go straight from looking at this to writing it right there. Okay? This one's not as easy to recognize as the next one we're going to do. The next one, you'll get used to recognizing it a lot easier. Let's do a couple of the squares, and then we'll go to the next kind. Let's do x squared minus 2x plus 1. You can factor it into 2 terms, or you could just recognize, okay, we know it would be x and x, right? And we know it's going to be 1 times 1. Is that going to give you that middle term?
Yep.
Okay, is that going to be plus or minus?
Negative.
It's got to be a minus. Minus 1x and minus 1x, right? If you recognize this as being this kind, you could have just went straight to x minus 1 squared. And if you don't recognize it, do it this way and then rewrite it, because it's the same thing twice. Rewrite it like that. Okay, let's do another one. This one, you're going to need to, oops, you do need to factor the 2 out first, like that. 2x squared minus 4x, I'm sorry, 40x plus 200. See, this term is not a perfect square with the 2 in front. You need to factor the 2 out first. Do that part first. Okay, what did you get for the first term? X squared minus 20x plus 100. Is this a perfect square? Is it something times itself? Yeah. 10 times 10, and that's a perfect square. So let's do that. Remember, we could do 2 of them, or we just put here, 10 times 10 is 100. So we put the 10. What are we going to put here?
Negative.
Minus. Okay? If you need to write it twice, go ahead and write the other one. And see that it's x squared minus 10 minus 10. And then that'll give you plus 100. If you don't, if you already saw that it was, go ahead and write it with the square here. Okay? So if it's not a perfect square in the very first part, like see this one wasn't a perfect square, you might need to look to see if you can factor out first. Okay, let's do one here. X cubed plus 24x squared plus 144x. Do we have perfect squares?
Yep.
X3 is not a perfect square. Huh? That is a perfect square, but what do we need to do first?
Put the x outside.
Factor out an x. So what do we have?
X plus 12 squared.
X squared plus 24x plus 144. Now are these perfect squares? Yeah. And A the square of the first one is x, right? The square root, I'm sorry, the square root of that is x. Square root of 144 is 12. 12x, if you double 12x, do you get 24?
Yeah.
Yeah, so that's a perfect square. And we need a positive one. So this squared. Okay, let's do one where we have to factor a number instead of a letter, like that one. 20p squared plus 100p plus 125. Okay, they won't all divide by 20. What will they all divide by? By 5? Yeah. And not a p, right? They don't all have p's. So just the 5. So what do we have in here?
4p squared.
4p squared. Divide that by 5 is 20. Divide by 5 is... Okay, is that a perfect square? Yeah, is that a perfect square? Okay, so 4p squared, what's the square root of that?
2.
2 and a p. What's square root of 25? And this is positive, so we'll put a plus. 2p times 5 is 10p, right? 10p, is that double? Does that give you 20? Yep. So that is a perfect square there. Now I'm going to jump back to the very first problems that you have to do. Because the first problems just tell you to determine whether it's a perfect square. But I think it helps to do it for a while to figure out whether it's a perfect square or not. Okay? Now we're going back to the beginning. Your first problem's on 5.5. Is this a trinomial square? I usually do them in order, but this one is better not to be in order. Okay, so I'm going to do number 4. You have x squared minus 14x minus 49. Well, x squared is a perfect square, right?
Yeah.
And 49 is a perfect square. Okay. Does it look like either one of those, though? This minus right here messes it up. It has to be a positive here, because when you do the last times the last, it's always going to be a positive. So if you see a negative right here, it's not a trinomial square. That doesn't mean it can't be factored in some way. It's just not going to be a perfect trinomial square. Okay, let's do number 8 says 25x squared plus 30x plus 9. Okay, so we definitely have perfect squares there, right? Okay, a is, the square root of that is 5x, right? What's the square root of 9? 3. Okay. If you look at that times that, you get 15x. When you double 15x, do you get that? We need to put a plus here, right? Well, it doesn't matter, we're not factoring it. But yes, it does, right? So yes, that one is a trinomial square. If you have to start factoring it to figure it out, that's fine. Okay, let's see. Number 5 says x squared minus 2x plus 4. Okay, first of all, is that a perfect square?
Yes.
Is that a perfect square?
Yes.
Okay, so when we do it, we would have an x and a 2. When we do 2x, 2 times x, when we double 2x, do we get the middle term?
Yes.
When we double 2x, we should get 4. So if this was a plus 4 or minus 4, it would have worked. But because of this, this is not a trinomial square. Looking at that, it was fine. It looked like it was going to be the right kind, but it's not. Okay? So that's how you do the first problems there for recognizing it. You may have to actually start doing the factoring to figure it out. Okay, let's go ahead and do a little more of this before we jump into the next kind. 16m squared minus 40mn plus 25n squared. What's the first term going to be? 4 times 4 is 16, right? M. And the last term? 5. N. 5 times 5 is 25. N times N is N squared. Okay, 5N times 4N is 20 mn, right? You double that, you get 40, right? We need the negative in here. Because it's got to be negative 5n times positive 40. So it's a negative 20 mn. So it's this squared. I'm going to give you guys one. See if you get it, and if you do, we'll go on. 64p squared minus 16p cubed plus q squared. What's first term? 8p last term? Q. Q? Negative or positive?
Positive.
If this is positive, it's positive. If it's negative, it's negative. So 8p cubed times 2 is 16p cubed. So that's good. Okay? Are we okay to go on? Yeah? I'm seeing a lot of nodding. Okay, our next form of factoring is actually, I think it's easier to recognize. Okay, it's called the difference. What does the difference mean you're doing to numbers? Subtracting, right? Difference of squares. This means you have two perfect squares and there's a subtraction sign in between them. So if you had a squared minus b squared, perfect square, you get the difference. Anytime you see a difference of squares, it's going to factor into, we know a squared is a times a. We know b squared is b times b. For there not to be a middle term, it had to cancel out. There had to be a positive and a negative. Okay? The baby likes this one better too. So it's unanimous, this is the best one. Okay? If you actually FOIL this back out, you should be able to get that back. First times first, a squared. Outside, negative ab. Inside, positive AB, and then the last times the last. Positive times negative, negative. BB is B squared. See how these two terms cancel out? we're gonna do this a little backwards again because it wants you to recognize them and then it wants you to start factoring them. We're gonna factor a few and then we're gonna go back to recognizing. Okay, let's do x, I'm getting mad at this pencil. X squared minus 36. That's a difference of two perfect squares. So first term will be x's, right? What's the second term's going to be?
Minus 6.
6's. 36 is 6 times 6. So you're going to need a positive and a negative. X plus 6, x minus 6. Is it okay to write x minus 6, x plus 6?
Yes.
Yes. You can put them in either order. Doesn't matter. I just normally put plus minus, so you'll probably see me doing plus minus every time. But it does not matter which order. How about 100 minus q squared?
Which is the key
First terms,
Q
10.
and 10.
Oh, okay.
This 10. Second terms,
Q.
q. And we need what?
1 minus 1 plus.
A plus and a minus, right?
I have a question.
Yes.
Can you rewrite it q squared minus 100 and then do it?
If you did, the q wouldn't be negative anymore. If you did that, it would be negative 1 times that. And that would make negative q squared and a positive 100. So if you did it the other way with the q plus and minus 10, it would have a negative 1 out here. And it's easier just to do this. Leave it in the same order.
Okay.
So if the number's first, you need to put the number first here. Okay, let's do 9a squared minus 16b squared. So what do we have here? 3a and 3a. And the second part? 4b. Oh, making me hungry. 4b and 4b. So we need a plus and a minus, right? Okay. Okay. If you need to be here, you could go to my office too. It don't matter.
She just wants to be at
She
your
wants
cars.
to be. Okay. We would even help you hold her. I would, but I'm busy. Okay. Let's try a different one. Let's do 16x minus 81 x to the third power. Are they perfect squares? 16 and 18 are, but these aren't. So what should we do maybe? Factor out the x. 16 minus 81, what? 2x squared. Now they're perfect squares, right? Okay, so the x is out here. 16 is 4 times 4. 81? 9 times 9, and you need the x's. So it's plus and minus. And you know it's going to go farther, right? Not this one, but we're going to learn more, right?
Yeah.
Okay. Okay, let's do one. 4x to the 4th minus 64. Are those perfect squares?
Yes.
Yes, good deal. Okay, let's put them here. 2x and 2x, right? Okay. How about 64? Okay, so 2x plus and minus 8. Okay. That has a lot of 2's that we could actually factor out, doesn't it? Maybe we should have factored 4 out first, even though it was a perfect square. Because I'll show you how. Because if we leave it like this, these can still be factored, like with the 2, like that. And this one, the 2 can be factored out like that. It could be factored out like that, and then 2 times 2 is 4, and then have x plus 4, x minus 4. Okay, that one can be done like that, or to get the same answer, let's factor the 4 out first, which is not what we would normally do, but it can factor out first. But see how you have the 2's in common, you have to factor it all the way out, okay? Okay, if we put the 4 out here, then we have perfect squares inside here. X, and then 16 is 4 times 4. Plus and minus. See, it factored the same, but we factored the 4 out first. So actually the first thing you're supposed to watch for is there a number we can factor out? A number or a letter? Okay, a variable or a number that we can factor out first. Since this had the 4 that could factor out, you could have done that first. If you don't do that first, you might not realize that you could factor the 2's out right here. So watch for the things that it has in common first, okay? Yes, ma'am?
If you factor those out, wouldn't that be like at the bottom here, where you have 4 and then the 4 plus x, 4 minus x? That's only going to be 4x cubed, or squared, right?
Those x's have to be.
Because you have it
Oh,
to the
squared,
fourth.
sorry.
You have it to the fourth
Oh,
power.
you know what? It's not totally factored in, is it? Because this should have been squared also.
Okay.
So let's kind of get rid of this whole thing.
Sorry.
Because you know what? This can still be factored right here. This part right here, x squared minus 4 is still something that can be factored farther. So let's start all over. 4x to the 4th minus 64. Can we factor 4 out? Yes. Okay. I just screwed up when I did it. And let me see. 4 is there. This is 8? No, 16. 16 times 4 is 64. This is a perfect square of x squared, right? Like you were saying. X squared plus 4 and minus 4. Okay. This cannot be factored. This is another perfect square. Okay, so this stays the same. And what will this be factored into?
I thought the 64 had to be squared.
The 64 could be squared?
The 8.
Yeah, it could be. Like we did it up here. We could have done it this way. But then you're still going to have to factor the 2 out of both of them too. We'll go back and do that one again if you want to. Okay, this one is going to be x. 4 is 2 and 2, so it's plus and minus 2. This should be the final answer. We'll do it the first one again by factoring the perfect squares. It's just going to take more steps than this. This took 1, 2, 3 steps. The other way may take 4 or something instead of just 3. Okay, perfect squares, we could do it 2x squared, and 64 is 8 times 8, right? That's how we started the other one. Okay, we need to factor the 2's out. That's factoring the 2 out of that one. We need to factor the 2 out of that one. Minus 4, right? Okay, 2 times 2, we'll put the 4 in the front. And then bring x squared plus 4 down here. We could bring this one down, or if you want to have it where it's the same number of steps as this, we could go ahead and factor this. X squared minus 4 factors into x plus 2, x minus 2. And it really doesn't matter if you do it where you factor the number out first, or if you do this and then factor 2 out. You can do it in either order. So if you didn't see that it's divided by 4, that's fine. Just keep watching to see if there's things you can factor out. And if you have it partially factored, when you're grading it, you can count half if you started it and you just didn't get it all the way factored. If you forgot to factor this part and you stopped like right here, instead, just count it half wrong because you just forgot to factor one part of it. Okay? Let's do another one that might take a little extra factoring. 1 minus y to the 8th. 1 is a perfect square, right? 1 times 1. Y to the 8th, is that a perfect square? Yeah, okay, so we can do that. So 1 is 1 times 1. Y to the 8th is y4 times y4. So we have a plus and a minus. Do we have another perfect square there?
Yeah.
This one is a difference of squares. Bring the 1 plus y to the 4th down. 1 minus y to the 4th will be 1. Y4th is what? Y squared times y squared. That'll be a plus and minus. And this is another reason it's better to put the minus second, because then it'll always be at the end. Is that a perfect square again? Yep. So bring the plus ones down. And this one will factor into what?
1.
And y. Plus and minus. We don't have a perfect square anymore, right? So that's going to be the final answer, which is a lot longer than the problem, huh? Okay, let's do x to the 8th minus 81. First terms, x to the 4th. Second terms, 81 is what? 9 times 9. So we have a plus and minus. Do we have another perfect square? This one? Yes. Difference of squares. The plus, it don't matter, you have to bring it down. That won't factor. Okay, what will this factor into? X squared and x squared. 3 and 3. And a plus and minus. Okay, so that's as far as you can go. The 3 is not a perfect square. So that one was a little shorter. It didn't keep going. There's some fraction ones, but you don't have any of those assigned. We can go ahead and do one just to make sure you know how to do it. X squared minus 1 over 25. Okay? X squared is x times x. And to get this, the 5's need to be on bottom. That's a perfect square, and 1 times 1. So if you multiply 1/5 times 1/5, you're going to get 1/25. Oops, sorry. I hit a button. I hate when it does that. So a plus and minus, and that would be as far as you'd have to go. Okay, now we're going backwards again. Recognize the difference of squares. Oops. Recognize the difference of squares. Is this one a difference of squares? Perfect square, and the difference. That's a yes. How about this one? Perfect square. It's not a difference. No. Okay, how about if it says negative 25 plus x squared? Can you rewrite that as a difference of squares? You could put the x squared in the front and then minus 25 behind it. Now that's a difference of squares, isn't it? So even though it doesn't look like it because there's a plus here, there is a minus there, so it can be rewritten as a difference of squares. Okay? How about this one? Oops. X squared minus 45. You have the minus. Perfect square. Is this a perfect square? No. So that messed it up right there. Okay, so you can recognize them now? Yeah? Okay, that's 5.5. 5.6 is factoring using a general strategy. Okay, so you could have any kind of factoring here. You may have just factoring one thing out, or you may have a difference of squares, or you may have a trinomial square, or a mixture of any of them, or they could even be prime. So what you're going to do is you're going to look at the problem. The first thing you're going to do is say, can you factor a number or a letter out? Is there a common factor? That's the first thing you're going to look for. Is there a common factor? And you factor it out if there is one. And then you're going to look for the special, like difference of squares. Look for the special products, like a squared minus b squared, like that kind, or the a minus b squared, or a plus b squared, those perfect ones that we've been doing. You're going to look for those special ones. If not, you're just going to factor it. If you don't want to do it by recognizing those, you can just jump from the common factor. You can jump to number 3, where you just factor it out. Okay, so the first thing, let's get a problem here. Oh, there was something else. When you're factoring, remember it could be just a normal factor, or you may have to group it. Remember the grouping ones too. If there's 4 of them, remember you have to group. If there's 4 different ones, the group is for if you have like an x cubed, and then you have something with an x squared, and then you have an x and a nothing. If If they have nothing, you can factor out, you know, with a common factor, and there's still 4 things left here, you're probably gonna have to group it. Okay, let's just go ahead and start factoring right now. Let's grab one. X to the 3rd power minus 5x squared minus 25x plus 125. Do we see a number common?
Fine.
This one doesn't have a 5. And they don't all have an x either. Okay, if there's no common factor, we are going to have special products because there's 4 of them. So we're probably going to be doing the grouping. Okay, group the first 2 and second 2. What do the first 2 have in common? X squared. So you have x minus, see, x gives you x to the 3rd minus, we need the 5, right? We already have the x squared, we need the 5. Okay, let's put this x minus 5 over here. What do we need to get this term here? Minus 25? Minus 25x, and then 25 times 5, 125, which is positive. So grouping is going to work here. X minus 5 they have in common. What's the other term going to be? X squared minus 25. Don't stop until you make sure that you can't go any farther. X minus 5 will not factor anymore, will it? Can this factor? What is it? It's a difference of 2 perfect squares, right? So you can still factor it farther. Bring our x minus 5 down. X squared minus 25